All right, pre-cal, welcome to your week 4 video guide. Again, I'm going to try to actually get through everything for the week in one video, maybe two. And so first thing we're going to look at is our curriculum guide just to see where we're getting these questions from. And this week we're really focusing on this standard right here, which is finding limits by substitution. And this DOK just means it's actually some of the simpler problems you'll have. You don't have to prove anything, go through any advanced work, quote unquote. It's really actually a pretty direct problem. Now, when we find limits by substitution, before we get into all the examples, let's just talk about what that means. It means that there are actually a lot of limits, and I'm just going to say this verbally, there are a lot of limits that can be found simply by plugging in a number into a function. So, if when you take the limit as x approaches c, so in other words, when we're taking the limit as x is approaching some value, as long as when we plug that into our function, as long as that outputs some number, in other words, actually, let me write it like this. If when we take our limit, we don't get 0 over 0 or 1 over 0, then the limit of x approaches c of f of x, this is kind of complex, is simply whatever you get when you plug in c. All right, in other words, you don't have to necessarily approach c for f to know what the answer is. Just plug in c and you have your answer. This is what we mean by substitution. You can essentially just say, well, instead of approaching c, just what do I get when I plug in c? And as long as it's not one of these two, then you have your answer. So that's going to really be the idea of our first two Khan Academy assignments. Now the idea here is limit as x approaches c equals f of x. Let's say this did give you 0 over 0. What this is called indeterminate form. And what it means is you actually can't say yet what it is. Now that is definitely something that is like impossible, but that's why it's indeterminate form. It's just a very special case, so exactly when you see 0 over 0, or later on we'll see if you see infinity over infinity, we call that indeterminate form, and what it means is there's something you can do to your function to where you can actually get a valid answer. And I'll really drive home how this connects to what you were doing in last week's assignments. You weren't actually looking at any particular function, but you were looking at a graph, and it turns out this whole 0 over 0 thing was totally happening in all those graphs. We just never explicitly stated that. All right, now, when you have the limit as x approaches c of f of x, and you get some form of a number, actually, I should say a number, so I'm just going to give that some value n over 0. If that ever happens, in other words, if it's a form of this, any number over 0, this does not exist. All right, in other words, this would be an asymptote case. If you ever have a value over 0, so let's say the value of c was right here. If we get this scenario, our graph is going to have, now it can change from problem to problem, but some shape like this. All right, and the idea is, if you think back to last week's assignments, if you're trying to approach c, well, from the left you're going up unbounded, you're going from the right down unbounded, and those are definitely not agreeing, they're not connecting anywhere, and so that's what makes it non-existent. The left and the right hand limits are not approaching the same particular y value. There's no kind of open circle where they link together. So in this case, whenever you get something over 0, you get to say, awesome, my limit doesn't exist, move on. If you get 0 over 0, that actually means stop. You can do something, some algebra to your function to get the answer. Right? So again, if you can just plug something into your function and get an answer that isn't one of these two, you're done. Whatever you got is the value of the limit. If you get 0 over 0, more work needs to be done. And if you get something over 0, you get to say the limit does not exist. So let's go through all of our Khan Academies with this in mind. We'll start by with limits by direct substitution. The hard part of this con assignment is going to be just plugging stuff in if you don't have a calculator. But again, it's called limits by direct substitution because what you're supposed to do is simply try to first plug in 1. If you plug in 1 to that function, that's 51 minus 2, and that's the root of 49, and so your answer is just 7. Right, up next, same idea. We need to find the limit as we approach -3. Let's first just try plugging in -3. And when you do that, make sure that's positive 9. Because of that double negative, you'll have plus 3 minus 1. So it looks like the answer is 11. All right, now when we approach -5, now, okay, this is a very important note here. This is the first problem where it looks like you could get one of these two, because this is the first problem where you're actually looking at a fraction. So in other words, once you see a fraction, that is where these two possibilities kind of start to show up. But before, we didn't even have a fraction, you just got a number. So just kind of keep that in the back of your head. Now we at least have a structure where in the future maybe we will see some of that 0 over 0 or something over 0 involved. Anyways, I'm supposed to plug in -5. When I do that, I'm going to get I have the 5 times -5 plus 4 over -5 plus 8. In the numerator, that's going to be -25 plus 4, so it's -21, over -5 plus 8 is just 3, and that reduces to -7. So again, it started off as a fraction. Now your answer still could be a fraction. You might need a slash for the denominator, but in this case, we actually just simplified to a whole number. Again, the reason we're not really stopping and saying, well, could it be something else, is because we didn't get 0 anywhere in this fraction. All right, and one more question. I'll just do this quickly. When you plug in -1, that would end up being positive 11, so 5 plus 11 is 16. When you square root that, you get 4. All right, so really all you had to do was just some very basic algebra for that assignment. Let's move on to assignment number 2. We're trying direct substitution, but this time it could be that our limit does not exist. All right, so again, we have a fraction here, so like I said last time, we could start to see some problems. We could get some zeros in our numerators and denominators. So let's try this out. When we try the limit as x approaches 1, I'm first going to try just plugging in 1 in the numerator. That's going to give you 2. And in the denominator, you'll get 1 squared minus 7 times 1 plus 6. And that ends up being 2 over 1 plus 6 is 7. -7 times 1 is -7. So we have 7 minus 7. So we have 2 over 0. Right? Now again, if you have some number over 0, that's DNE. So in this case, the limit does not exist. Because 0's in our denominator, we have some other value in the numerator, we know our limit does not exist. All right, moving right along. This time, when I try direct substitution in the numerator, 1 minus 11 is -10, and 1 plus 7 is 8. This time, I end up reducing and getting -5 over 4. Again, I don't have 0 going on. I don't have 0 over 0 or something over 0, so I'm totally safe. I just get the -5 over 4. All right, up next in this example, again, when you plug in 2, I'm just going to go a little bit more quickly. Your numerator will be 4, your denominator will be 0. So we have a number over 0. We've seen that before again. If that ever happens, there's nothing that you can do. It just does not exist. All right, and we've got one last example here. When we plug in -5, that numerator is essentially going to read -4 parentheses squared over 8 minus -5. Now that's going to end up being positive 16 when you square it. This will have a double negative and give you 13. Again, you don't have 0 anywhere, totally fine. Now I guess the last thing I'll say in this video, or at least for this part, is if you ever just simply get 0 over any number, that is just 0, right? 0 over anything is just 0. Again, to kind of draw this idea home, I'm going to look to my calculator for a second. Again, if I write 0 over any number, I'm just going to randomly choose, I don't know, 12. That's 0. Again, if it's 12 over 0, if 0 is on the bottom, we've been saying that's DNE, and you can see that the calculator says, blah, 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 error, is long story short. Now, in that case, when it's just 1, 0 on the bottom, that means there's totally no answer to your limit. If I write 0 over 0, you'll see the calculator gives you the same answer-ish. There's some error, but when it's 0 over 0, we haven't seen that yet. There's some more work you can do. That leads us into our third assignment.